This screencast is how to find the pH of a salt. So in this particular problem, they want us to calculate the pH of a solution of sodium cyanide. So the first thing you're going to want to do when you look at a salt is we need to decide which ion came from something weak. So here are the two ions that I'm dealing with here, sodium and cyanide. I know that sodium came from the base, sodium hydroxide. Now that's strong. Cyanide polyatomic ion came from this acid, hydrocyanic acid. So this one is weak because it's not strong, so this is the one that we need to deal with. This is the ion that's going to interact with water, and that's going to give us our pH of this particular solution. So when you start with this, you need to decide which ion of the salt came from something weak, and that's the one you need to focus on. That's the one that's going to interact with water. So this is a hydrolysis reaction, which just means how it's going to interact with water. It is going to be at equilibrium, and cyanide is going to come in here and steal a hydrogen and become this and leave water as this. So that's my hydrolysis reaction. I also know that if I had a 1 molar of this, then I have a 1 molar of the cyanide ions. So that's going to be here in my initial concentration. Okay, I'm going to do an icebox and we'll write an equilibrium. So before cyanide reacts with any water, I don't have any of these. And once it starts interacting, I'm going to get some of these. How much? I don't know. So plus x minus x. We don't really need anything for water there. And so this is going to be x, this is going to be x, and this is going to be 1 minus x. Okay, so now we're going to need an equilibrium expression. They tell us here the Ka is this. Well, Ka is an acid dissociation constant. What the reaction I have here is not a reaction that has to deal with an acid. This is a solution that is most definitely going to be basic because I'm going to have some hydroxide ions. So I don't need a Ka, I need a Kb. So to get Kb from Ka, it has to go through Kw. So Kw divided by Ka will give me my Kb. So Kw is 1 times 10 to the negative 14 always. That's that water self-ionization constant. And then the Ka they give me is 6.2 times 10 to the negative 10. That gives me a Kb equal to 1.6 times 10 to the negative 5. Oops, 5. All right, so let's write this reaction. So Kb is going to be HCN times OH negative over the concentration of Cn negative. And now I'm just going to plug everything into this, and I have 1.6 times 10 to the negative 5, I want to use that Kb, is equal to x times x over 1 minus x. Well, x is going to be pretty small. We can tell by our Kb. So in relation to other numbers, x can cancel out. And I'm going to end up with x equal to 0.00402. X is my hydroxide ion concentration. So now I can find my pH. First I have to find my pOH, and then I can subtract my pOH from 14 to get my pH. So my hydroxide, to find the pOH, it is the negative log of my hydroxide, and then 14 minus pOH will give me my pH, and I get 11.60 since it looks like I'm dealing with 2 sig figs, just dealing with that Ka right there that was given to me. And so the solution is basic. It is a basic salt, which is what I would expect from this sodium cyanide.